Hi, so today we're going to talk about precipitation reactions, otherwise known as how to write a net ionic equation. So here's the basic overview of writing a net ionic equation. First, you write down the basic equation, which is the formula AB plus CD, yield arrow to AD, it yields AD plus BC. Now all that means is that the first compound or the first ion mixed with the second ion in the first compound plus the second compound, which is the next two ions, those shuffle around. And so if you shuffle those around, you're going to get the result on the other side of the yield arrow. And we'll talk more about that in a second. The second step is now that you have the equation written, you need to balance the equation, obviously. Then after you balance the equation, step 3 is you determine if any possible combinations of these ions in this equation produce an insoluble product. And you're going to do that using the solubility rules or the solubility chart, which I'll show you a copy of. Number 4 is after you determine which is going to be soluble and which is going to be insoluble, you take all the soluble compounds and you break them up into their individual ions. And you'll see more about that when we get to it. Number 5 is that now that you have all of the individual ions broken up in the equation instead of paired with their compound buddy, you're going to cross off any of the ions that appear the same on both sides of the yield arrow. And these are called spectator ions. And then number 6 is that you just rewrite the equation, everything left not crossed off, and that's your net ionic equation. So let's try an example of this and take a look at it. First, you're going to write the basic equation, and this is going to be in the formula of AB plus CD yields AD plus BC. Now, as you can see right here, we have the start of an equation. We have AgNO3 plus CaCl2, and then yields what? We don't know. Well, we can very easily just call this first ion, the Ag, we'll call that A, and then the nitrate, we're going to call that B. This calcium is C, and this chlorine, or chlorine, or chloride, because it's going to be an ion, is D. Now, so on the other side of this yield arrow, we're just going to reshuffle these ions around, and we're going to write first AD, which would be the Ag, and D would be the Cl2. Plus Bc. So the B is the nitrate. And the C is the calcium. So now this isn't a real equation yet. We're just getting the framework for the equation right now with what we just wrote down. So so far we have AgCl2 plus nitrate calcium, or calcium nitrate. When we rewrite this again, we can switch this around so it says calcium nitrate, but it's fine the way it is right now. Now that we've written that basic equation, we have the silver and the chlorine, that's your AD, and then we have the nitrate and the calcium, that's your BC. You make sure each out of all of these, here's your each pairing of this, there's one cation and one anion. Like this silver, the Ag is a cation and the Cl is an anion. The nitrate is an anion and the calcium is cation. So you want to make sure that these go, oops, calcium's 2+, sorry. So you want to make sure that when we put these together in the formula, that the cations and anion charges are even, make a zero charge compound. So when we're writing these, the Ag is that cation that is 2 plus. That's 2 plus. So, and it's pairing, its ion, we're pairing it with chlorine. Chlorine is going to be, I just lost my train of thought. So chlorine is going to be a 1 negative charge. So we're going to need 2 chlorines to make a total of 2 negative charge to when we pair it up with the silver, which is a positive 2 charge. So together, that would be an AgCl2. And then plus, now we have to do the nitrate and the calcium. So nitrate, NO3, has a charge of -1, and calcium, the cation, has a charge of 2 positive. So we're going to need 2 nitrates with a charge of 1 negative each to add up to even out the 2 positive for the calcium. So let's write calcium first since it's the cation. Here's calcium. And then we're going to need to put the nitrate in parentheses because we're going to have an additional subscript on there saying 2 nitrates, so the charge will even out with the calcium. So this is the actual ending of that basic equation with the charges balanced out. So see how we have it written nicely now. So AgNO3 plus CaCl2 plus AgCl plus calcium nitrate, NO3, 2. So there's 2 nitrates to go with the calcium. Now that we have that, we need to balance the equation, obviously. So you always have to balance the equation at the beginning of everything. So the balanced equation, I'll let you do that on your own. You probably already know how to balance equations. So the balanced equation is 2 moles of AgNO in AgNO3 plus calcium chloride plus 2, or yields 2 AgCls plus calcium nitrate. Now that we have the balanced equation, we need to determine if any of those possible combinations of those ions in that balanced equation are going to produce an insoluble product, or are they going to be all soluble with water. And the way you do that is you have to look up a chart on a chart, and it depends on your teacher whether or not you have to memorize this chart or not. But you need to look up on a chart or have memorized the solubility rules. And that will tell you if the compound in a reaction is soluble, and so that's when you put the aqueous sign after it, or if it's insoluble, you put the solid sign after it. So let's look this up. Let's look at the solubility chart. To your left, the one on the left is just the table listing all of the soluble and insoluble rules. To the right it's the same information, but it's just rearranged in a little matrix for you if that's easier for you to understand. They're both the same information. But as you can see, here's the soluble ones are the cations are all the group 1 ions, the alkali metals. So lithium, sodium, potassium, rubidium, cesium, and francium. Although in general chemistry, you don't really go down that far on the periodic table. And also ammonium, NH4. And then the anions are the nitrate and acetate. And then you have some anions that are soluble, usually soluble, except when they're paired up with certain other elements. So chlorine, bromine, and iodine, or chloride, bromide, and iodide, are they're the group 7 elements down the middle of the periodic table, and those are soluble unless they're paired with silver or copper or mercury 2 or lead 2. And also the sulfate, unless they are with barium, calcium, mercury 2, lead 2, or strontium. And those are all the chlorine, bromine, and chloride, bromide, and iodide, are in the group 7. And unless they're paired with some of the transition metals here. And the sulfate is soluble unless it is paired with the group 2, which is the barium, the calcium, and then also some of the transition metals, the mercury, lead, and strontium. And then the insoluble compounds are hydroxides, the OH, unless it's paired with, going back up to soluble rule number 1, the cations up at the top of that chart, the group 1 ions, the alkali metals, lithium, sodium, potassium, rubidium, and ammonium. Those kind of trump everything else. So if hydroxides are insoluble, if they are paired with these very soluble cations in group 1, then they're fine. And also the hydroxides can be paired with the bottom half of group 2, calcium and strontium and barium, and they'll be fine. They'll still be soluble. And then carbonates are insoluble unless they're paired with group 1 cations or ammonia. Going back to rule number 1, the rule number 1 soluble cations, which are the group 1 ions and ammonium, that trumps any other rule. So if that's paired with something that's insoluble, it's going to be soluble because you're going to go by group 1's ions and ammonium, which are soluble cations. I hope that makes sense. Phosphates are also insoluble unless, of course, they're with group 1 ions or ammonium, and most fluorides, unless they're with group 1 cations or ammonium. Now that we know what the chart is for the solubility rules, we're going to look at our equation here, and we're going to write after each compound whether or not that compound is soluble, which if it's soluble, then you're going to write aqueous, and if it's insoluble, you're going to write solid. So here we have this written out. The 2AgNO3 is definitely soluble, so that's aqueous. The calcium chloride is aqueous. Now, the only thing that's solid on here is going to be the silver chloride over here on the right side of the yield arrow. That's the product. And what is solid, that is what the precipitate is. The precipitate is the thing that turns solid and separates itself away from the solution. Also, the other one, the calcium nitrate, is going to be aqueous. Oh, so I don't need to underline that. So once again, the only solid thing is this 2AgCl. Now that we have all of those labeled, now we can go ahead and change this into the an ionic equation. Now what you do is you take everything that's aqueous and you're going to break these up into individual ions. So this AgNO3 is aqueous, so we're going to take the Ag and put it separate. And we're going to take the nitrate and put that separate. And again, why didn't I separate the nitrate into individual nitrogen and oxygen atoms? Because we're not dealing with atoms on this level, we're dealing with ions. And nitrate is the ion that is going into this solution. So we keep nitrate together, but we're just going to separate it away from the silver. Now calcium chloride is also aqueous, so we're going to take the calcium and we're going to move it over here, separate it out. We're going to take the chloride and we're going to separate it out. We're going to leave this solid alone, this silver chloride. Just leave it alone. And we're going to go over here in this calcium nitrate. We're going to separate these ions out because these are aqueous. Now there's something else that we have to do. You notice that I didn't write down all the subscripts on these or the moles, the coefficients on these yet. We still have to deal with that. We have to go back and do that. So if you look at this first one, the 2AgNO3, there are 2 moles of AgNO3. So this 2 right here, this coefficient 2, applies to this whole thing, this AgNO3. So there are 2 moles each of each of the silver and each of the nitrate. So we have to go down here and we put a coefficient of 2 for 2 moles of silver, and then we have to go over here and put a coefficient of 2 for 2 moles of nitrate. Now let's move on to the next compound, this calcium chloride. Now this whole thing goes together, but there's no coefficient in front, so there's only one of these each. Now, but if you look at the chloride though, there's 2 atoms of the chloride, so there's 2 moles of the chloride itself in this compound. So we have to include that in just the chloride only. So we're going to go down here and we're going to make that one of the coefficient for chloride, not for calcium, because calcium doesn't get that 2 subscript. That's why it's written in a subscript and not the coefficient. But so we're going to bring this 2 down here and we're going to turn it into the coefficient because we're saying there's 2 moles of chlorine. Now again, we go back and we skip the solid one, and then we go over here to the very last one, and if you notice, this whole thing is all together, but there's no coefficients here, so there's only one each of these, except over here, the nitrate, there we had to have 2 of the nitrate ions in order to keep the charge even with the calcium, remember? So we have to take that into consideration for the nitrate only. So we're going to bring the 2 down and we're going to write that 2 as a coefficient because it's just because this is separated out now. So we can write this as a coefficient saying that we need 2 moles of nitrate in this formula. Now let's just put pluses in between all of this. All of these people or all of these little elements. Pluses in between all of this. And now let's bring down the solid and just rewrite that exactly as it is. And we'll write a plus in between here. And then here's where the yield arrow goes. Okay, so now this is our new ionic equation. It's not our net ionic equation yet, but it is our ionic equation because these are all separated out into their individual ions if they are soluble or aqueous. And here it is written out all pretty. Now the next thing that we do is we cross out. If you notice, these ions repeat themselves on the other side of the yield arrow, or at least a couple of these ions do. If you notice at the product end of the yield arrow, we have calcium as one of these ions, and we have two nitrates as ions over here. And if you look at the beginning in the reactants, we have a calcium ion right here, and right before that we have two nitrates. They're exactly the same. This is exactly the same as this, and this is exactly the same as this. So we can cross these guys out. They cancel each other out because they're both exactly the same on either side of the yield arrow. So let's just cross these guys out. Now what we have left, we just bring down. So we have 2Ag. This one's crossed off. This one's crossed off. So let's bring the 2Cl down. 2Cl. And let's put the yield arrow in. And then let's just bring the solid down. We don't do anything to the solid. Just leave the solid alone because that's our precipitate. So we're just going to rewrite that exactly as is. And then calcium is crossed out, and the 2 nitrate is crossed out. So that's the only thing we have. The solid was the only thing we had left to write down on the yield arrow. Oh, and let's go back in between this 2 silver and 2 chloride and put a plus sign in there. So now now that we have these spectator ions all crossed out, the ions that are the same before and after the yield arrow, those are crossed out. We've rewritten the ones that are left. The equation that's left, after everything else is crossed out, that is your net ionic equation. So see, here it is written all pretty. So 2 silvers plus 2 chlorides equals 2 silver chlorides. And that's it. And that's your net ionic equation. Here's again is the overview. And here's your solubility rules.